Hi everyone. Hey, we are starting our last chapter of the year. Yay, statistics. And with this, we are going to do something totally different from what we've done all year. And we're also going to use some new curriculum. So you're going to see a few things that are different. And hopefully you'll catch on to that and appreciate it. So first thing we're going to talk about is what is a normal distribution. Well, in statistics, the word normal has a very special meaning, and especially when we talk about normal distribution. And a normal distribution, we're going to actually look at some examples and non-examples of what normal distributions are to get a really good feeling of what a normal distribution is. So in this task, you'll be given a pair of data distributions, and they could be histograms or distribution curves, or some might even include some box and whisker plots. And your job is to look at them and compare and contrast. So I want you to look at them and decide what is similar about the two distributions, what is different, and what makes one of them normal and one of them not normal. And then I want you to discuss this with your neighbor. So I'm going to pause on the video for a little bit, give you some time to think about it and talk about it with your neighbor, and then we'll start back up talking again. Okay, so here's the first comparisons of distributions. So look at the one on the left and one on the right. And what differences do you see in the distributions? And also, what do you see that is similar? And then notice the one on the left is approximately normal. We call it a normal distribution, but the one on the right is not. So I want you to discuss with your neighbor why. Why is the one on the right not a normal distribution? Okay, so some things that you hopefully talked about with your neighbor is they both represent histograms, and you can see that they both increase to kind of a central point and then they decrease. You notice that the one on the left is symmetrical. So that is one term that we're going to talk about with normal distribution is symmetry. Normal distributions are symmetrical. The one on the right is not symmetrical. You can see that the data is more spread out on the left, a little steeper on the right. So we call this skewed. So this distribution is skewed. It is not normal. And it is actually skewed left, which I kind of think of it like this. It looks like it's been pushed from the left to the right. So that's why it is called skewed left, or that's just how I remember that is skewed left. Okay, here are two more contrasts, curves to contrast. The one on the left is normal, the one on the right is not. So I'm going to give you about 15 seconds to discuss these with your neighbor. What is common, what is different about these two curves? Okay, go. Okay, so some things that you should have noticed is the one on the left is called a normal distribution. It's symmetrical and it looks like it's in a nice bell curve. And notice that the mean, median, and mode. So we're going to use mean, median, and mode quite a bit. So let's talk about those for a quick second. Mean, median, and mode are measures of central tendency. They're very common in statistics. So mean, tell your neighbor what the mean represents. And you should have said that the mean is the average. And how we find the average is we add them all together and we divide by how many data points that there are. Okay, now tell your neighbor what is the median. And the median is the middle number if you line it up from smallest to biggest. The mode is what? Tell your neighbor. And the mode is the one that occurs the most. And it's quite possible that a set of data doesn't have a mode, because if all the numbers are different, then there's not one that occurs the most. Or it could have more than one mode. So like, for example, if you have a set of data that has 2 4s and 2 5s and all the other numbers, there's just one of them, then your mode would be 4 and 5. So that's what a mode is. Now, in a normal distribution, the mean, median, and mode, if there is a mode, are all the same value, or very similar, very close to the same value. In a not normal distribution, notice the one on the right, the mean, median, and mode are in 3 different places. So that one we can tell is not normal. Also, we can tell that this one is also skewed. This one is skewed right, because it kind of looks like it's being pushed from the right. Okay, here are 2 more sets of data. Can you tell me the differences between these? I'll give you about 15 seconds. Go. Okay, so the one on the left obviously is a bell curve. It's labeled bell curve. The one on the right is not. It is not symmetrical. It is skewed left. They are very similar. They are both histograms. And a histogram is showing data points, and it's not just the height that matters. The height represents how many of those data points that there are. So that's, remember, histograms. And one more. I'm going to give you 15 seconds to talk about the differences and similarities between these 2 distributions. Go. Okay, so the one on the left is a normal distribution. It looks like a normal bell curve. A couple things that this brings into it, and this brings up a lot of the vocabulary terms we're going to talk about. Points of inflection. So a point of inflection, notice on this curve, it's curving up, curving up, curving up, and then right here at 1 standard deviation, it kind of switches, and it's very imperceptible, but you can kind of tell that now it's curving down, curving down, curving down, and then we get back over here at positive standard deviation, and now it flips, and now it is curving up again. So that is a point of inflection. Some other things on here is this symbol right here. Is actually this one here. I made it bigger and not so fuzzy. So this is called the Greek letter mu, and we use it in statistics to represent the mean. So if you ever see that, if it says like mu is equal to what, then you are looking for the mean or the average. Also, your calculator uses X bar for average. So that's another variable that we use for average. So if you ever see mu or X with a bar over it, those both represent the average or the mean. And then you've heard me talk a little bit about standard deviations in here. So a standard deviation, hopefully you've heard that term before. A standard deviation is measuring how far from the center or how far from the mean, the average, are all the data points. And we have a lovely little formula that shows us how to find standard deviation that we will use later. But just for now, The variable that we use for standard deviation, you can't see it very well there, it's fuzzy, but it's sigma, and it's a 0 with a tail. So standard deviation just tells how far data points are from the average. So if I said it's 1 standard deviation away, a positive one, that would be 1 to the right, or a negative one would be 1 to the left. And 2 standard deviations, and 3 standard deviations, and so on. And we're going to talk about like how far data points are from the value in standard deviations. Now back to the one on the right, it's obviously not uniform. It is not symmetrical at all. And it also has 2 kind of peaks or more. So this is not unimodal, or in other words, one node. A node is kind of like a peak in data. So this one has several nodes in it. So obviously the one on the right is not a normal distribution. Okay, here's the next one. I'm going to give you 15 seconds. Talk with your neighbor about why is the one on the left a normal distribution and why is the one on the right not. Go. Okay, so notice the one on the left is symmetrical. It also has a nice bell curve to it. The one on the right is not symmetrical at all. It doesn't have one node. It has several nodes in it. This actually has 3. We call it trimodal. So obviously not a uniform distribution or a normal distribution. And another one to look at, I love this one because it compares a histogram and a box and whisker plot. So try to remember everything you know about a box and whisker plot and compare them to these histograms. Look at the one on the left. Why is it considered to be normal? Why is the one on the right not? Give you about 15 seconds. Go. All right, so let's talk about the box and whisker plot that is above this normal distribution on the left. So normal distributions deal with the mean. So that is the middle. But do you remember how we find box and whisker plots? So a box and whisker plot still takes all the data, just like a normal distribution, but it divides it into 4 pieces, the quartiles. So 25% of all the data is represented in each of those quartiles, quartile 1, 2, 3, and 4. With the center 2 being the inner quartiles, they make up half or 50% of all the data. And then the whiskers represent the 25% on each end. So this is also different from the normal distribution because box and whisker plots don't have the mean as the center. What is it that they use as the center of the box and whisker plot? So if you remember, they use the median. Because the box and whisker plot, you line up all the data from smallest to biggest, and the median is the middle, and then you find the quartiles by cutting the data into fourths. So the one on the left, you can see that the box and whisker plot is symmetrical, just like the normal distribution. The box and whisker plot on the right is obviously not symmetrical because it's not a normal distribution. And also notice that the median would not be lined up with where the mean or the average would be. So I love how these compare and contrast box and whisker and normal distributions. Okay, last one. What do you see about these